Test, test. Right. I'm sure they'll tell us if it sounds weird or not. Test.
Hey everyone, Michael Unger here at the MacMillan Space Centre. We had a bit of a power outage, but we are here live to do another session of these Astronomers that we always do every second Thursday at 2 o'clock. And we are not in the Space Centre, we are actually in the Museum of Vancouver, who we share the building with. So shout out to the Museum of Vancouver. Thank you for letting us use your spaces, which of course is located on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh. And with me, as always, sitting across from me, hopefully our echo issues have been worked out. We'll cross our fingers. And that is Marley. Hey, how's it going, Marley?
It's good. I'm so hesitant with the echo because I hear you slightly delayed from over. Yeah, but it's good. I'm glad that we got a little bit of sunshine while we were out and about with our power outage.
Yes, we had a very adventurous morning. We had a school group here, and then the power went out, and then we went out to set up some solar scopes. The sun is shining. We did briefly look at the sun through some solar filters, but we have lots to talk about. For all of you that are here, this is your first time at Ask an Astronomer. You have, the next 30 minutes while we're here in our show. If you have any questions about anything in the universe, throw them into the chat, and Marley and I will do our best to answer them. And of course, if you're watching on Telesoptic, you can come in and ask live questions here on YouTube if you like next time. But we do have some stories that that Marley has prepared. So let's start off with some of those stories, Marley.
Okay, you'll have to bear with me as I'm on my 1 monitor setup instead of my 2 monitor setup. So I am still figuring everything out, but I wanted to kind of loop back to what we talked about last week with the whole Artemis mission, because they were supposed to be doing their wet dress rehearsal this week, and they did start, but how far they got was something else to be desired completely. Let me just pull up these slides if this computer likes me enough to let me do it. There we go. Hopefully, can you see anything, Michael?
Not quite yet, but as we're coming up here, maybe let's remind everyone what the Artemis mission is. So Artemis is the next moon missions that are going to go to the moon. Apollo was the last time humans went to the moon. That was the 1960s and 70s. Now Artemis is going back into Greek mythology. Artemis is the sister of Apollo, which I think is really fun. And these missions coming up that you're about to talk about are the next iterations of humans going to the moon. Is that right, Marley?
Yeah, and the Artemis One mission is actually to start us, getting people back. We want to do everything untested first without people involved because we don't want anything unfortunate to happen with any astronauts on board. And so the whole Artemis One mission is meant to be uncrewed. So no one will be on board. It'll have no human beings on board. It will just be more of a test of technology mission to make sure everything's working okay. And part of that is the wet dress rehearsal for the rocket. And that is the SLS, the new type of rocket they have developed to get us back to the moon. What they have to do with that is they have to prep all the fuel, go through all of the launch stages before they can actually launch the rocket for their full mission to make sure that it'll work, because once we launch it, that's kind of all that we've got, right? There's only one big one as far as I know. And so launching it and having it break or otherwise something happen would not be ideal. So that's the whole point of the wet dress rehearsal. And it's a good thing they did it because they ran into quite a few problems when they first started getting it together. So finally got my slides to work.
I think we talked about this last week, but wet dress rehearsal means that you're actually doing it, but without the humans. Is that what wet means?
Yeah, so wet dress rehearsal is doing almost everything except for the actual launch itself. So the rocket doesn't actually launch itself, but they go through the entire fueling procedure. They get everything in before, and then they get it fueled up. They go through the entire thing, and then they stop, right? They don't actually let it launch, and then they take all the fuel out. And one of the big problems with the Artemis when they started this wet dress rehearsal that they started is that the oxygen actually would not stay cold. It started to warm up, which ended up being a very, very big problem with the whole thing. Okay, finally, several years later, hopefully you can see my screen now. It should be the rocket, right? It's visible.
Yes, we can see
Okay.
a beautiful picture of the SLS, right?
Yeah, so that's it on the launch pad. They actually built a whole new launch pad as well for the SLS to be able to sit on a whole new launch system. There's several different things, new technologies that have been developed to do it. But yes, this is the SLS, and its problems kind of started with the full wet dress rehearsal. They started doing it on April 1st with anticipation for the whole rehearsal to be done by April 3rd. But they ran into some problems with a lot of the computer technology on board as they were going through this process. And most recently, they ran into a problem with, I said, the liquid oxygen not staying cold enough. So liquid oxygen, when it's being put into the spacecraft, has to stay at a temperature of like -270 something Fahrenheit. So very, very, very cold. It has to be kept very, very cold and chilled. And it started to warm up as they were loading it. And they got the tank about halfway full. And what I had on the slides before the power went out and I lost all my work was a cutout view of the SLS that shows how big the tank is. So in that orange part of the rocket are actually two different fuel tanks. And then there's two different of the side rockets on the side, but they got halfway filling that up before they started getting the errors, and they had to remove all of the fuel and go back and address the problem. And so to my knowledge, they haven't actually put another date for another wet dress rehearsal attempt. It'll hopefully be in the next week or so. But that May 2022 launch is looking a little less confirmed. That'll probably be in June, I think, if we continue to have these problems.
So I'm not sure if you have another slide to show this, but if we want to stay on this slide, Marley, because you did talk about the fuel tanks that are attached to the SLS. So if we just look at this picture, the orange part, right in the middle there, that's the main fuel tank. There looks like there's another fuel tank on the sides. And so the actual capsule where the astronauts would go is right near the top. Is that correct?
Yeah, so where the astronauts are actually going to go in this image is that the very top, that pointy bit, right below that is where the astronauts are actually sitting. That's the Orion Capsule, which is a new capsule that was developed specifically for this mission. And so that is where the crew cargo will be. And so we need this large of a rocket to get, what a very small looking thing all the way to the moon, like equivalent to the Saturn V, right? Think of how large that rocket was for the Apollo missions. We needed something with the same amount of power, but redesigned to be more efficient and kind of with the technology that we've developed since the lunar missions back in the 60s and 70s.
Okay, we did actually have a question that came in at the end of last week's Ask Astronomer, which I thought this would be a good chance to maybe address this, because we do actually get this question a lot, which is why we are sending humans back to the moon. And of course, there's many thoughts that are coming up of all of the issues that are happening here on this planet. But of course, even just scientifically, what is the advantage of sending humans back to the moon at this point?
The advantages of going back to the moon now really fit into the wider context of two different larger astronomy focuses. So there's the whole idea of going to Mars, sending human beings to Mars. Mars is what we consider a deep space location. It's very, very far. It takes about, with the current, what we have, like 9 months to get there. And to do that, we need to figure out what the people we send will need, what different problems could arise being there in such a hostile environment for such a long time. And it would be foolish to just send people to Mars when we have the moon right there, where we could go and test all this technology first before sending it to Mars, the same way that we test everything we can on Earth before we send it to the moon. So going to the moon fits in that sort of sense. We can test everything there in a more, better environment for testing things when it comes to Mars versus Earth. The second reason is just looking at how our solar system evolved and how our solar system formed. The moon is it's about as old as Earth, a bit younger, but it because it has no atmosphere and it is not geologically active, so there's no lava or anything moving around in there, no continent shifting, it's kind of like a time capsule. And it could show a lot of information about planetary evolution and minor body evolution and things like that, how things form in the solar system from the very beginning, because nothing much has changed there. Also learning more about how we got our moon, like Earth and our moon, it's much, much different compared to other planets and their moons, especially in terms of size, right? The moon is about a quarter the size of Earth, whereas Jupiter's moons, think about how large Jupiter is, their moons are about the size of Earth. So quite a weird, like we have just a very big moon considering how big our planet is. And so there's also evidence of water on the moon. So going back and studying that more, how does water exist on a body like the moon? And can we apply that knowledge to other bodies in our solar system? So the moon isn't just like, oh, let's go to the moon. There's actually a lot of scientific and engineering reasons to go back there.
Yeah, and I think it's interesting to, and I have to remind myself of this as well, is that when we're seeing these missions in the here and now, we think about the issues of here and now. But when we are going out into space and exploring space, we're not just exploring for now, we are exploring for the future, which is a future that might be too far in advance for us to see. But when it comes to planning missions, these missions that are the Artemis mission of going back to the moon has been in works for decades. And even right now, there's actually a really interesting process called the decadal survey, which I'm sure you're aware of, Marley, which is figuring out what the next big missions are going to be. And for NASA, this is sort of like the research group to try to figure out what the next big missions are. And of course, some of those big things are going to come up, more going back to Mars, maybe going to Venus. We've got several of those missions right now. Some of the more intriguing ones that I've heard about is potentially going to Uranus and Neptune. And what boggles my mind is like thinking about just starting to plan for a mission to Neptune or Uranus is several generations of scientists. So the scientists that are going to work on that right now will not see it through to the end. And so I find that really wonderful, thinking about the exploration we do in space. Even as a scientist, even as a space lover as myself, we start thinking about things that we know we'll never get an answer to, but we are always on a continuous journey towards it.
Yeah, if you want instant gratification, this is definitely not the field for you. It takes a while to get results back and to get the information back, especially going to Uranus and Neptune. That's going to be quite a long way down the road. Think about the New Horizons mission that went to Pluto recently. They launched that almost a decade before they got things back, and they only received about 20% of the data so far that it's had to send back. And so it is more of you have to look at the big picture in terms of these types of missions and things like that. You're not going to get the immediate result you want as soon as the rocket lifts off launch pad, right? It's going to take a while for everything to come back.
Wonderful. So let's move on. We do have another story to get to. Of course, if you're just tuning in, we did have a larger presentation, but we lost all of our power, which is why we're here in the Museum of Vancouver. But if you'd like to join in the conversation, throw some comments into the chat. So there was another story that happened with the Canadian Space Agency recently, Marley, some unfortunate sad news.
Yes, okay, now my slides are, there we go. Yes, one of the original 6 Canadian Space Agency astronauts passed away this week. I'm very sorry, I will not be able to pronounce the name. It is Bjarni, and then a last name that starts with a T and lots of Y's, and is not one I'm able to pronounce, but he did pass away recently. He was involved in several of the Canadian Space Agency missions. He flew on the Space Shuttle Discovery and was one of the original 6 Canadian astronauts. So quite a sad moment for the Canadian Space Agency and Space Society community.
Bjarni is what we called him. He actually visited us here at the Space Center quite a few years before my time. I never actually met him, but he did come through these doors before. So our condolences to his family, and of course to all of the Canadian space fans out there as well. So Marley, we've got about 15 minutes left before the end of the show. Yes, Keith, I'm going to type his name into the chat. That would be good, so that other people can look him up. Are there any other big stories that are on your radar recently, Marley?
There was one. The whole point of this Ask an Astronomer, I was going to do Artemis and astronaut updates, because there's quite a few astronaut updates, including the passing of Bjarni, and then also a couple other stories that have happened. If you've been following long extended space missions, Mark Vande Hei returned to Earth a few days ago, setting a new record for an American astronaut length of time in space. The new record is now 355 days living in space. The previous record was held by Scott Kelly, who did 345 days in space. Now we have a new record. Vande Hei, Mark did a press release a few days ago, I think maybe 2 days ago, where he was talking about reacclimating to Earth, and he said that it's going a lot faster than he thought it would. So he's doing okay. The reason he spent so long on the space station is part of NASA's, again, growing attempt to learn about what happens to the human body for extended stays in space, right? The average mission on the International Space Station is about 6 months. So they don't stay incredibly long. So staying for almost a full calendar year is a very, very long time. And it does take its toll on the body, both mentally and physically. And so studying that will help us learn what to prepare for when we do longer stay missions like going to Mars. So that was Mark. Welcome back to Earth. I hope you don't drop anything important while you're back with the gravity change. So, but he says he's been doing fine.
Oh, that's wonderful to hear. And of course, there was some concern, of course, of some of the Russian astronauts that are still on the space station and working together. It's like an interesting time where there are Russian astronauts and American astronauts still collaborating on this project that was always a collaboration with Roscosmos, the Russian Space Agency, NASA, and the European Space Agency. And one of the things that we always like to reiterate here is that space is universal. Space is for everyone. You know, one of the main reasons why the International Space Station came to be was to bring all of the nations together on a collective exploration of space. And I believe that most of the people that are in these programs do truly believe that, even if politically there is some disconnect and obviously some very awful things that are happening to the Ukrainian people. But as far as space goes and that collaboration, it seems to be that they still have a very good working relationship.
They kind of have to, like, you're in effectively a tin can, you know, hurtling around the Earth, and things go wrong, and things can go wrong very, very quickly up there. So you have to work together, and you have to be able to, you know, work together with the people you're up there with. And when you look out the windows in the space station, there's no borders on Earth, right? So that stops mattering pretty quick when you're up there. So I didn't anticipate there to be any tension on board between the cosmonauts and the astronauts. Like I didn't think that would be a problem, and so far it hasn't been, and I don't think it will become one. They have a job to do, and they're there to do it.
It certainly will affect some of the projects going forward, though. It certainly could affect the future of the International Space Station. There was already talk of Russia leaving that partnership. But there is also the European Space Agency's collaboration with the Russian Space Agency, given the ExoMars mission that was supposed to go. There was supposed to be a new Mars rover that was supposed to go up on a Russian rocket, but that has now been put on hold, right?
As far as I know, that's been put on hold again, which is, it was supposed to launch in 2020, and then it got delayed to 2022, and now it has been delayed again. That is, the ExoMars 2022 mission, or whatever year it'll be now, has been delayed. And so it has, you know, conflict on Earth will have a direct impact with institutions and stuff that do with space work, especially with regards to the ISS. Like, that was already something that Russia was going to pull out of, that Roscosmos was going to pull out of. It just may accelerate that, but NASA's already, you know, has a decommissioning plan for the International Space Station in place. I know they were anticipating using Russian, I'm forgetting the word now, but they, not rockets, but they attach to the space station to propel it downwards towards the Earth. But they are testing a different type of spacecraft system that's American made to see if that could also achieve the same amount of thrust needed to get it down. They're testing that, they're looking to test that. So, and then of course there's the Soyuz rocket, right, is what has been used many times to send astronauts and bring them back to and from, not bring them back, but send them up the Soyuz, which is a Russian spacecraft launching out of Kazakhstan there. And so there may be problems arising with that as well, with will we be going over there with trade embargoes and things like that. But again, that's where, you know, there starts to be talk of private corporations stepping in and filling that role. We have the SpaceX mission coming in as well, that will start to begin doing that, and is actually sending a new mission AX1 to the space station. I think they're launching tomorrow, actually. That was the last story I wanted to share, but my everything crashed and I lost everything. But they will be going to the space station, I think, tomorrow for private people, and they'll be on the space station for a few days for private citizens. So that there's talks of like that niche being filled by private corporations, and as that starts to pick up more and more in space industry.
Yeah, it's interesting how that was already starting to happen. You know, the private space agency was already, you know, making big leaps and bounds in their contribution to space exploration. And now it seems like they're going to play an even bigger role now as nations, you know, these challenges come up. So certainly there's going to be lots of development on that throughout the year. We've got a few more minutes. We've got about 9 more minutes. So we did actually have a question come in from Wellington. So speaking about the evolution of the solar system, going back to the moon, that helps us understand about that, potentially exploring Uranus and Neptune. We've never really been out there, only done some flybys. Of course, Triton is certainly a world that I think we're very interested in. But a world that Wellington is interested in is one of the dwarf planets, and that's dwarf planet Eris. What can you tell us about Eris, Marley?
I think Eris is the one that gave Pluto the boot. I think was that one. Is that we developed Eris, discovered Eris, so we were like, it's smaller than Pluto. Should it be the planet? And kind of triggered the big debate, or just accelerated what was already a debate. But the dwarf planet Eris, interesting as well. Like once you get to those planets further out, like beyond like the ice belt, quote unquote, they're made up of different materials than necessarily the moon. There is chances of different collisions having happened with those versus objects like our moon and asteroids. The idea that water is frozen in those more icier, rocky ice worlds is very interesting. But again, it's getting there. That's a very big problem, right? Like Voyager, the 2 Voyager missions, you know, took a very, very long time to reach the outer edges of our solar system. The New Horizons mission took a very long time. So getting all the way out there takes a very long time. It's still worth studying? Yes, I definitely believe it is worth studying. Like we can get there, it just takes a minute. But as regards to Eris, it's interesting and a world that would be interesting to go discover, learn about. But there might be other candidates that may be more reachable than Eris.
Yeah, and I'm almost wondering too, with a lot of this discussion about if we do want to go back to either Neptune. I think Neptune is certainly a world that is on that list of potential places to go. Triton, of course, is going to play a big part in that because Triton is a captured dwarf planet, or I guess like it was a captured world, and so going to Neptune would also mean going to Triton. So the scientific value of maybe choosing that place over going to Eris might be more, or perhaps you can go to both. Perhaps if there is a mission that can go to Uranus, go to visit some of Uranus's moons. And I also heard some very interesting other moons of Neptune as well that are very intriguing that some scientists would like to go to. But basically what we're talking about is small worlds that are very far out in the solar system. Pluto being, one of the first that we've really only to fly by, but really starting to understand that there is more going on with these small worlds than we had originally thought.
No, there's always more, right? And that really comes back to the more technology is able to increase, the more we're able to know, and that gives us more questions, which means we have to build better technology to answer them. And it's a really a never-ending cycle when it comes to, I think, all aspects of science, but it's very especially seen in astronomy and in space science. But yeah, they're far away, hard to get to, but that doesn't mean any less reason to look at them. It just means we got to figure out how to get there in a better way, maybe.
Pride says the Yoko Ono of the solar system, which I don't know if I agree with, because I recently went to the Yoko Ono exhibit at the art gallery, and I think Yoko Ono from my books is way cooler than John Lennon. So that might be like a controversial statement, but after seeing the Yoko Ono exhibit at the art gallery, I think I'm a Yoko Ono fan.
I don't particularly care for either of them, so there's that.
Absolutely. So I've got a few more minutes left, Marley, but we do have a very big event that we're going to be doing actually here at the Space Center in a few weeks. So maybe let's spend the last few minutes to talk about this event. We have Megan Russell coming up from the Planetary Institute in Colorado. She's going to be making an in-person appearance, and we're going to be doing a hybrid event. We're going to be doing online as well as in person, and we're going to be talking about Venus, Earth's twin. That is our main theme for this month here at the Space Center. It is Earth Day coming up as well, but we have decided to look at Earth Day and think about this world that has been almost kind of neglected. Speaking of worlds that have been neglected, Venus really has been a world that has been neglected over the last little while, but soon won't be because there are many missions heading there.
Yes, there are 3 big ones headed over in the 2030s, 2 NASA missions, 1 European Space Agency mission, Envision, Veritas, and the Da Vinci Plus missions. I think Envision is the ESA one. I've talked about them so much that I forget which one. They're just the 3 Venus missions, but I think Veritas and Da Vinci Plus are the NASA, Envision is the ESA mission. But all 3 will be going to Venus. All 3 will be doing, kind of similar things, but also different methods of doing it and slightly different things. But they will be looking at Venus's atmosphere, using radar to look at its surface because we can't really go down. The only difference is Da Vinci Plus will go down there. It will orbit and then drop through Venus's atmosphere to the surface, and forever long it lives, but it will take image and data as it goes. So that mission I'm particularly interested in just because I want to see if it'll crush like a tin can, but I'm sure they've accounted for that given Venus's immense pressure. So those are the ones that are coming up. I'm excited for the planetarium show. I've been working on it. It's going to be very fun, very interesting, and I'm excited for Megan's talk as well.
Yeah, I think you just looked at some of Megan's images that she sent over. If you give us a short little preview, what could we expect on that event?
So I don't want to give too much away and also give up Megan's opportunity, but it will be about Earth and related, Venus and Earth related. It's often talked about as they're 2 sisters, right? Sister planets made out of the same stuff, but doing like more of a deep dive into Venus and why it is the way it is, what questions scientists have about it, why its surface is particularly interesting, and what we can learn from the upcoming missions that we'll be launching in the next few years.
Excellent. So that is going to be on April the 21st. And like I said, there's going to be a hybrid event. We'll have a bit more going on. If you buy a ticket for an in-person event, we'll have a live science demonstration as well as the planetarium show, and of course a chance to get close, not too close to Marley and Megan here in the building. But we will also be live streaming the planetarium portion as well. So you can go to our website, spacecenter.ca, to check out more of that. And as well, we've got 2 more Star Wars related events coming up as well. On May the 4th, we're going to be having an online event. I have just confirmed our special guest. I'm not going to give that one away just yet. That's going to be a really cool on May the 4th. That's going to be an online only event on May the 4th, and May the 5th, we're going to be doing an in-person event, and we will be also be doing some fun shows that'll be looking at the universe through the lens of Star Wars. So again, some really fun events coming up for you to check out. And that's it for another edition of Ask Astronomer. Thank you folks so much for checking us out here. We'll be online again in 2 weeks right here on YouTube at 2:30. I also see someone talking about our Twassen Mills exhibit that Marley also worked on as well. We did contribute to that. That is opening up soon. You can check them out on their website. That is the Twassen Mills. I'm not too sure what the exhibit is called, but it is certainly looking at the universe, and we contributed to the history of the exploration of our solar system to that exhibit. I have not seen anything yet, but I'm looking forward to going out there soon. Yes, that's it for this edition of Ask Astronomer. Thanks so much, folks. See you next time.